Well, hello there, dear viewers. How you guys doing? Hope everyone's doing well. Um, I am in a less of a weird mood today, so hi. Hope you guys are doing well. Um, and yeah, so last time, I pushed all my changes to the repository, right? Um, we had our game running, recreated our map, and you could go into the map and you could go and create a map from a map file, and we kind of went and parsed this file, which is kind of cool, right? We did all of that, and that was awesome. But this is it for this part of the project, as in, like, we're done with the part of you know creating the map, essentially, right? Or loading the map. So what I'm gonna jump into now is actually build the map editor. And so I'm gonna start working on that now. So we're essentially gonna close everything. Say goodbye to everything. All right. So I'm gonna create a separate project, right? The map editor is gonna be a separate project. I'm gonna right click here, create a new project. It's gonna be a C++ empty project, and this is gonna be called map editor. And yeah, gonna click on create. Going to show all files, map editor. I'm going to go and see what's in there. Oh, not terminal. I want to open it in the terminal. Ooh, okay. Alright, so here's our map editor. Here's our RPG game. And you open the project and it opens this. Kind of cool. Alright, so we're gonna start with, we're gonna have to reconfigure this entire project to work just like how we reconfigured the RPG game. So this is very annoying, but we'll have to do this all again. But luckily, I mean, we have most of the work done, right? So I'm just gonna copy and paste stuff, right? So this is the map editor. I'm gonna right click on the RPG game. So all configuration. I'm gonna copy this, paste this over here, copy this here. What else do I need? More important. All right, we need before all configuration. Copy this, paste it here, this over here. Our linker, or sorry, our preprocessor, we need to, for release, going to be SFML static. Need this. And finally, for our linker, we need for release, I copy all this. It's gonna be for release. Then for debug, different. Copy all of this. And this is debug over here. Alright, so essentially we're gonna do the same thing here and reconfigure the same exact thing. So we'll start from here, all configuration, all platforms, right? Gonna click on edit. It's going to be this, copy. Then over here, copy, and alright, we're done with that. Click on apply. For this, same exact thing. edit, paste that. All right, so we're done with this. The linker is also going to be the same exact thing. Ooh, not the linker. Well, the linker is going to be release x64. This is the linker data here. And we're going to do the same thing for debug. This. We've done all this already before. You know, nothing here is new at all. But there you go. Finally, I need to create a main file so I can see the C++ part. So you notice here, the C and C++ is not appearing if I click on the map editor, right? That's because we need to, and we talked about this before. I need to create a main file. I'm gonna create a C++ file. I'm gonna call it main. Right, and then go here, and you can see C++ appeared. So the preprocessor, this is for all configuration for everything. Edit, make sure you press on inherit, and we're just gonna do a final step here. Apply, done. All right, so when you test this, we need to actually make sure it works. So I'm gonna go into the main function, copy all this code, and paste it over here. Right, and we're gonna start deleting some stuff. Delete all this code. Delete all this code. Delete all this code. Delete all this code. Delete the clock. Well, we cannot do any clocks. We keep the clock again. Definitely delete all this code and definitely. Right. I'm gonna set this to a black color. I don't understand why it's red. Let me go back here and also make sure it's black. No idea why I set it red. Anyways, so in theory, if this is gonna be map editor. So in theory, if I press play, this should work just fine. Well, it's gonna run the RPG game. Okay, so it's gonna run the RPG game. Now, here's the thing: when you have multiple projects in Visual Studio, whichever one has the bolded letters, that's the project that's gonna run when you press start. What you could do is I can right click on Map Editor and click on Set as Default Project. And what that would do, you can see now Map Editor is bold. So if I press play, that will run the Map Editor. All right, so we have a bunch of errors. It can't find the library SFML graphic SD, which is interesting because it is supposed to find it. So let me just go dependency SFML lib. Do not have the dash D. So which one did it find? SFML graphic S graphic SD. There it is. So it can't find it, which means this path is not correct. Oops. So the path is supposed to be the RPG game dependencies SFML lib. That's correct. Why can it not find it then? It's set in all configuration. Processor corrupt. This is weird. Am I forgetting something? Hmm. How can it not find it? What? Makes no sense. Rebuild? Cannot open file? Can't open it. Okay, what about if I go to release and rebuild this? Nope. Same issue. That is so strange. I mean, the reason it wouldn't find it is because there's an issue with the path over here. There is no issue with the path, and you can see here the path is correct. So the RPG game dependency lib right there. That is interesting, I gotta say. Oh, input. Oh, fine. What? This is not all. Oh, I put this in the wrong place. I'm such an idiot. This is supposed to be in library. I put it in external includes. Alright, we're gonna cut this. Click OK. Well, I have to. All configurations, all platforms. Like, what am I doing? Cut. Press OK. Put this in library dependent. Such a silly mistake. Anyway, so now this should work if I rebuild this. Yep, it does. It works fine. Press play. Or let me go to debug mode. Press play. And you can see here's our editor, right? Empty, nothing inside it, which is good. And if I go to map editor, oh, it's in build. Oh, now they're mixed. No, I don't like this. You can see the map editor and both of them are mixed. No, we can't have that. Okay, so we want to go here, and this has to change now. It has to be build slash project name. What's the project name? Oh, there's a macro for that. Right? Project here. Project build name, right? Which is map editor. I'm gonna copy this, paste it over here. Okay. So map editor. So the RPG game build map editor. And I'm gonna copy this. Okay. Same thing here. So build map editor. Apply. So we need to do the same thing for the RPG game. The RPG game has to go into RPG game. Right. So RPG game. RPG. Okay. Let's go ahead and delete the build folder now. Rebuild the entire solution. We create the build folder. We create the map editor RPG game. Map editor, you go inside. You can export, debug, bin, all the stuff only for the map editor. Same thing for the RPG game. All right, cool. So this is all done, and if I go press play, I should be able to see the map editor. All right, this is awesome. All right, so the hard part, well, the boring part is kind of done. Not the hard part. The hard part is still coming. But the boring part is kind of done. So what I need to do now is, well, the first thing I need to do is kind of, build. How about we build a grid? Right, that's what I want to do. First thing I want to do. I want to build a grid, right, of lines. So That's really what I want to do. It's the first thing, right? And it's pretty simple. So what I'm gonna do, I'm gonna create a new class. I'm gonna call it the grid class. So grid. All right. All right. So here's my grid class, looking beautiful. Absolutely fantastic. All right. I'm gonna call my grid class over here. I'm just gonna create an object out of it. Where just to keep think. Oh, I need to make a source file folder. So I need to make a crc, not ct, crc, and assets. So crc is all of our code, right? And just to be consistent, I create the objects over. I need kind of it's fine. All right, so I can create what is there to initialize? Let's initialize. Oh, what is there to initialize section? Do I have the same thing here? Yeah, so you have initialize and I have initialize over. Oh, that. Alright, so here's what I'm gonna create my object. I'm gonna do grid, and so same thing as always, grid dot initialize dot load grid dot update, and finally grid dot draw, which we need to pass the window to it. Yeah, I need to include my grid class. Right. So I'm just gonna go here and kind of copy a bunch of this code because it's boilerplate code that we've done a million times. Copy all of this. The header, I'm just gonna paste it, and I'm just gonna delete it. Right, and this is gonna be our constructor and destructor, which is grid. I need to include the SFML graphics header file. And I need to initialize everything, or just generate all these functions. Our load doesn't take a file name, so that's unnecessary. Move it from here. But there you go. This is our boilerplate kind of class that we always have. We always use, right? And so if I press play, this should work again with no issues. Nothing will happen. Ooh. Doesn't take 0 argument. Yeah, I need to press delta. Right? If I press play, everything should be the same. Alright, cool, great. So what's next? How do I draw the lines now? That is the question. Well, if I go to the SFML, go Google, SFML, check out the documentation. And graphics drawing shapes. And if you remember correctly, we did find out how to kind of draw a line and just a rectangle shape, right? So we're gonna do that. We're gonna create an SF rectangle shape. I'm gonna call it line, right? And I'm gonna do window.draw line. And initialize, I'm just gonna say inner line. Dot, I don't know. Line equal SF rect shape. which is going to take a size. Yeah, it's going to take a size. It's going to be an SF vector 2f. Let's do 1 and if I press play. Oh, 1 and 1 is 1 pixel and 1 pixel. What am I doing? 100 and let's do 5. You can see there's a line over here, and I can change its position. Let me put this in the constructor, like so. Initialize, I can do line dot set position USF 100 and 100. This will move the line 100 pixels to the right and 100 pixel down. 100 pixel down. The line over here. All right, that's pretty cool. So I have a line, right? The line is a little bit too thick. Maybe let's do 2. I don't like them. I don't like my line too thick. Lines thick, but there you go. And so what I can do now is I can figure out, right? I can do some math and figure out how long my line is in terms of size. And that math can be done really easily. So initially, I'm not even going to do this, right? I'm just going to do line dot set size to be SF vector to F 105. So this is 102. So this is going to be the same thing, except before we were doing in the constructor. Now we're just calling a set size function, which does that. Okay, so we need to figure out how long this line is. So it's very basic math, right? The whole thing is very mathematically basic. So let me grab my hold on. Let's assume for a second. Well, we're not gonna assume. We already know how big each of our tiles are, right? We kind of have that information. And so if I go here, and I go to my assets and maps, and I check how big is every single tile. So every tile is 16 by 16 pixel, right? Let's say I want 10 cells. So that means I want 1, 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, right? So each one of these cells is 16 pixels. So this is 0, this is 16, and then 32, 54, 92, 128, right? And so on and so forth, right? Each one of these cells. So I don't actually know 16, 32, oh, 48. How about 48? Okay. 48. Grab. All right, cool. So, oh, why did I do that? 16 plus 16. All right, 32, 48, 64, 80. 80, 96. Right? 112, 128, 144, and 160. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are 11 cells. We need only 10 cells. And end up connecting. Right. So these are 10 cells. 0 to 9 is 10 cells. And so we know if we want 10 cells, then we can take 10, multiply it by 16. Right? And it'll give us this entire length. All this length over here. Right? And so pretty simple. 10 by 16 is 160. Right? We have 10 cells. This goes up to 144. What do I do? Oh, this is what? I forgot the 8. Got the 8. 8, 9. There you go. These are 10 cells. Right? So we take 10 because we want 10 cells, and so 10 cells multiplied by 16 gives us 166. So we know this line should be 166 pixels to cover the entire grid if we want 10 cells, right? And so we can, those are, basic math thing that we can do, which is cool. So what I can do here is do the same. If I have 10 cells, 10 by 16 pixels, and I know there are 16 pixels, then it's 166, right? So I'm going to create a variable, and this is just temporary for now, right? I'm going to say int total cells on x equal 10, int cell size on x equals 16, and so int line width is it, or length? Line length. Yeah. Or we say horizontal. I butchered the word horizontal there. I spell that right? Spell that wrong. Of course I did. Horizontal line length. Right? There's gonna be all cells multiplied by this. And this is gonna be how long it is, right? And this is int horizontal line thickness equals 2 pixels. This, right? And then we need to create a few things. Int grid position. I'm just gonna do position. Right? And this is gonna be actually SF vector equal SF vector 100. Cool. And so if I press play, this should give me a lovely line, which is not 166 pixels. Is this 166? I don't think. 10 by 16. Huh, is this really 160? Looks a bit smaller. Yeah, I guess it is. Cool. This is 166 pixels. All right, so we have that, right? Because every cell is 16 pixels, and we can say we can have a scale if we wanted to, which we'll deal with it later. So now, how many cells do we want, right? So we made the single line, which is good, which is great. We made the single line. What about the horizontal line, vertical line, right? So basically the same exact thing. We want to make, this is H line for horizontal line. I'm gonna draw an H line, right? And then I'm gonna create another line. This is gonna be V line, right? And so I'm gonna copy essentially this code. It's gonna be V line, V line. I'm gonna copy, well, this is going to be Y. How many cells do I want on Y? Well, I only want 5, so half, right? How big is every single cell on the Y-axis? It's also 16 by 16. This is the int vertical. I spelled that correctly. Hey, look at me, I can spell. All right, vertical line thickness is also 2. Why would I want one of the lines to be thicker than the other? I think that's a horrible feature. Just gonna call it line thickness method. Right? So this would be vertical line length. Gonna be y, and there. Right? However, this is gonna be a little cool. This is gonna just be on top of it, right? Because we need to swap these. Actually, hold on, swapping these. Oh my. The position. So these lines are always Oh, I didn't render the line. The line. Right. There you go. I have my vertical line, which is half of this, right? Okay, cool. But this is all great, but then this is not a grid. We just made 2 lines, right? What we actually should have, let me run this application. Yeah, I know. Get my back pen over here. Right, what we should actually have is a line. Oops, need the white line. A white line every 16 pixels. Right? And then every 16 pixels are horizontal line. This would be our grid. Right? And this is our grid. This is what we want to do. So we can put these lines manually, right? We can go ahead and just copy this and horizontal line number 1, horizontal line number 2, horizontal line number 3, horizontal line number 4, right? Or we can make this as an array, right? Which we have worked with before. So we're gonna make an array, and this is gonna be an array of 10. This is gonna be also an array of 10. In fact, this is gonna be an array of 6, right? Okay. So this is cool. And we're gonna comment all of our code that we currently have. Well, not this. This is kind of useful. Okay. So now I need the for loop. This is gonna be on the y-axis, right? And so this is what I have in my head. This is what's gonna happen. We're gonna draw the first line, and then go down 16 pixels. Draw the second line. Go down 16 pixels. Draw the third line. Go down 16 pixels, and so on and so forth. And we're gonna do that 10 times, right? And so here we're gonna say how big? That's 10 horizontal line. We have 10 horizontal lines. Actually, this is 5. We're gonna have 5 horizontal lines and 10 vertical lines. I'm just gonna hard code these numbers for now. We're gonna fix them later. Okay. So we're gonna say horizontal line for every horizontal line at y. And I can keep this at I. I don't have to keep it at y. I is fine. Right? I dot. I'm gonna copy these 2 lines over here. This, and this is now I. Right? Copy this, paste it over here. Copy this over here. Now I'm rendering a I. And there you go. If I press play, I should, in theory, see. Oh no, that's not gonna work. It's gonna be all 10 lines on top of each other. So the question now, right? These are the positions. This is the position of every single line, right? And so This is the position of my grid. Think of this as the offset of my grid, right? So what I'm going to do, I'm going to do plus SF vector 2F. And I don't want this to be moved on the x-axis. I don't want this to be moved at the at the x-axis at all, excuse me. But I do want it to be moved on the y-axis. What I can do I multiplied by cell size.y. And so how this is going to work is very simply, and we've done this a million times, but we're going to draw a line, right? I is 0. Let's start from the very beginning. I is 0. 0, this is 16, right? You can see it's over here, 16. I by 0, or 0 by 16, it's 0. So we're gonna draw the first line at this position with no offset. And then I increments by 1. So now is I1. 1 by 16 is 16. So now we take the position, which is here. We go down 16 pixels, and we're drawing the second one. And then I goes to 2. So 2 by 16 is 32, right? So plus the position. So this is the position. I'm going to go 32 pixels, and then draw the second line, and so on and so forth, right? I'm going to keep doing that. And so if I press play right now, you can see all my lines. We have 1, 2, 3, 4, 5. 5 lovely lines, which have 16 pixels between them. All right, so we're done with this. How about we do the horizontal one now? Well, same exact thing. I'm just going to copy the same code, paste it. It's going to be V, going to be 10, because, well, remember, we have 10 vertical lines. And instead of putting this on Y, we're going to put this on X now. This X, and this is 0. And then obviously render everything, right? So this is going to be 10 lines. And it's going to be, if I press play, it will work perfectly. Well, not really. I messed up something. If you remember, those are flipped. All right, flip them. And there you go. We have our grid. The beautiful grid. It's a very tiny grid. It's a beautiful grid. Now, I don't think I've explained why I flipped these, right? If you think about this, this is the line where the line starts, like drawing, and where it ends. So think about the size for a horizontal line. For a horizontal line, I'm saying the length on the x-axis, it's 100 pixels. And the thickness of this line is 2 pixels. So it's going to be like this. This is 2 pixels thick, right? And here I'm doing the reverse. I'm saying the thickness of my line on the x-axis is only 2. This is how big my line is on the x-axis. But on the y-axis, it's this big, right? So that's how I flip them, right? On the x, it's 100. And then on the y, it's 2 for this one. On the x, it is 2. But on the y, it's 100, right? So it's now vertical. So there's the good. All right, done. We made our lines. They're beautiful. The only issue is we need an extra line on the right and an extra line at the bottom to kind of cap off or close off our grid. So instead of doing 5, we're gonna do 5 plus 1, and I'm gonna keep this plus 1, and I'll explain why plus 1. Right, and then I'm gonna do this plus 1, plus 1, plus 1, plus 1. That should cap everything up, right? You can see here, I'm gonna magnify, but I don't think it's gonna show up on stream when I use the magnifier. If I magnify, or you know what, I'm gonna take a screenshot. That'll be a bit better. So, a screen. One problem currently with our grid, that if I paste this, zoom in here, do you see that we're missing a single pixel over here? This lovely pixel here, we're missing a single pixel, right? So we need to add that. It's not that important right now. We can figure it out in a bit. And the reason we need to add that is because this single pixel, it's not there. It wouldn't be an issue if our thickness is 1. So if my thickness is 1, this would be perfectly fine, right? Actually, no, it's the same. Never mind, I'm wrong. But yeah, we need to add a single. All right, cool. So we have a grid, right? This is grid. It's great. It's fantastic. It is absolutely the greatest grid that ever existed. There's a problem with our grid right now. It's very tiny. So what I can do is dot set scale SF vector 2f. We're gonna do 10, call it 10. Do the same thing. That should scale our grid by 10 times. It should be much, much larger. Well, okay, it's a little bit too big. Maybe 5 times. Maybe 10 times is a bit too. All right, so 5 times looking good, right? But remember, whenever you're doing the scale by 5 times, not only have to do this scale 5 times here, but the distance over here you have to multiply also by the scale. Technically, the scale should be at the very top. Actually, no. I'm gonna ignore the scale. I'm not gonna set it from SFML. I'm gonna set the scale here manually. So I'm gonna do int scale x equal 5, int scale y equal 5. And so the scale, this is gonna be the same. This is gonna be same. Setting the size the same. The scale is gonna differ in how long the line is, the horizontal line is, right? So just multiply by scale. Multiply by scale. Then we're gonna multiply by scale over here, and then multiply scale over here. This hopefully fix our issue. So we can see much bigger grid. Now I can control the grid here. If I wanted scale of 2, it's now much smaller. Right? So on its scale of 10, you can see much larger, right? And that's pixels still off, by the way. I can still see it. Might be a little bit hard for you to see here, right? But it's still missing a pixel over here. Okay. So let me explain. Why did I first of all, why did I decide to make the scale the way it is right now, right? Why did I just do SFML scale? Well, the problem SFML scale is gonna scale the thickness too, and I don't want this thickness to be scaled at all, right? I just want the length of the tile or the length of the line, how long the line is. I just want that to be changed, right? And so here, this variable, the horizontal line length, specify the distance, right? We said we have 10 cells and we have 16 pixels, which means the line is going to be 166 pixels. However, if I multiply this by 5 or 10, I'm going to scale this by 5 times, right? And same thing for the vertical line. If I say I have 5 cells, right? I have 5 of them, right? This distance and the cell size on the y, how long it is on the y, if it is, I don't know, 100 pixels, I'm scaling that by 10 times or 5 times, so now it's increasing in length, right? And so that's that. Those are the length of the lines. The next part is this. This is the distance between each cell, right? So the distance between each cell is only 16 pixels, right? Like this. If I multiply it by 10, it's 166 pixels. Now it's much larger. So I just increased the distance over here. Right? So now each tile is 166 pixels. But that's not completely true. I mean, yeah, it is, right? It is 166 pixels, but basically I'm just saying, hey, the tile is 16, but I'm scaling everything 10 times so I can see it a little bit better, right? That's pixel art. You take your pixel art, you do it at 16 pixels, but blow up everything or scale it by 10, you can see it a little bit better. Right, and that's our grid. We've done our grid. It's a pretty cool grid. I'm still really annoyed by this pixel at the very end. This pixel here that's a little bit off. It's annoying me, and I kind of don't know why. Like, it's not off over here. You can see it's not there. Like, it is here, but can see this pixel here. Missing a pixel. I'm not quite sure why that is. Why does this happen? Why am I missing a pixel? Oh, I think I know. Okay, I know why I'm missing a pixel. Let's think about it for a second. Think about this for a brief second. I'm saying that every line, like this entire line over here, this whole line, is let's say 166 pixels, right? And then this line is also 166, right? And so on and so forth. So this line is 166, and I'm starting this line at the very top, at this position, and it's going all the way down, and it's all the way down at, and it's the length of this line is, I don't know, 164 pixels, every single one. But they meet up over here. So technically this line ends over here. So let me just draw this. This line, this vertical line over here, this line ends over here. Right? This is where it ends. Right? So there's this gap. This gap is being filled up by this line. Right? However, when we reach the corner, this gap is not filled because this is where the line ends. It's at 166 pixels. So we either need to make this line a little bit longer or this line a little bit longer. Just a tiny bit. One of the two. And so it's a simple fix, right? So I can do I can just do the horizontal line. I'm just gonna say +1 pixel. I'm gonna increase it by a pixel. Or 2 pixels. Because it's the thickness, right? Yep, it's 2 pixels. So I'm just gonna increase it by the thickness. If I set the thickness to 5, you will see that we're gonna still be off. You can see how. I do 10. Let's a little bit more clear at 10. Alright, you can see it's still off. So simply all you do, you just increase one of these lines, either the horizontal or vertical, doesn't matter. Increase it by a line thickness. So make one of the lines a little bit longer. You can see it fills up this gap. Kind of cool. Let's go back to 2 pixels for the thickness. But there you go. This is our grid. It's a beautiful grid. All these variables need to get the fuck out of here, essentially. So yeah, all these are supposed to be in here. And I'll explain why I did the +1 in a second. I'm gonna copy all these, specify them with the constructor. I can make this vector because xy, xy, xy. I can make all these vectors. I might just do it that SF vector 2i scale. SF vector 2i. Total cell size. Total cells. I could just do that. Then the change. This would 10, comma 10. 10, comma 5 would be 16, comma 16. And line thickness. There we go. Oh god, this would be dot x. Dot x. Dot y. Dot y. Dot y. Dot x. Dot y. Dot x. Dot x. And dot x. Alright, cool. Code is a little bit cleaner, a little bit nicer. Position will be also set over here. Let's set the position vector to f. And this vector to f position will be like this. That's fine. Just set it over here. Right. That's the position. Alright, there you go. If I press play, same thing. I should have everything over here. $50 thickness? Alright, you got it, buddy. Here's 50 thickness. Why not? Make it as thick as humanly possible. There you go. All the thickness in the world. How does that look? Is that satisfying? Is that how you'd like to see it? Super thick. Alright, cool. So we have all that set up, which is kind of cool. Now I'm gonna explain why I have this at 5+1, right? So first of all, we did the +1 for the extra line at the very end for the grid, right? So if I just delete all these over here, you'll see it's gonna be missing the extra line. And we talked about this and we've done this, right? So why didn't I just do 6 and 11? Well, it's much easier in my head to figure out that if it's 5+1, then I know that there's 5 cells and 10 cells, and the +1 is for the extra line, right? So that's why I do it like that, and it's kind of easier in my head. So what I'm gonna do, I'm gonna create a preprocessor. I'm gonna call it total lines on X, and this is gonna be 5+1, and it's gonna be total lines on Y. Actually on Y, horizontal. Yeah, Y is 5. This is 10+1, right? So on X, I have this many lines. On Y, I have this many lines. And I have these defines over here, which is awesome, because now I can use these defines everywhere, rather than having to change this stuff. So over here, which is kind of cool. Okay, here's the thing. I could have made this as a variable. I'll explain this in a second. Let me just go through all this. So this is over here and over there. All right, cool. So this is done. If I go here, press play. Thank you. Right. It's the same exact thing. Now, and the cool part is if I go here and I decide one day I want this to be a 5x5, and if I press play, this would work. I will have a 5x5 grid, hopefully. Well, and then we have to fix this, but we'll fix it. That's an issue we'll deal with in a second. But there you go, right? I can just specify how many cells I have, and all I have to do is just change these variables, and it will change the code everywhere, rather than me going change the code over here and then change it in this loop, and then kind of change it in this loop. And so that's why variables are kind of awesome and useful. But here's the thing. Why didn't I make this? Why didn't I make this a variable? Why did I just create a preprocessor, right? As you know, a preprocessor, what it will do, it's the first stage of your compilation process, right? So it's gonna go scan your code. It's gonna look for this word. Once it finds this word, it's gonna replace it with this. That's literally what it's doing. right? And notice we don't put a semicolon over here like we do everywhere, because if you put a semicolon here and it sees this word, this is what's going to happen. It's going to take 10 plus 1 and the semicolon, right? The preprocessor, all it does, literally, copy paste. It replaces stuff. So we don't want a semicolon. Okay, so now the question, why did I create a preprocessor directive and not a variable? Well, a variable, think about it. A variable will take memory. It will take a certain chunk of memory when the application runs. However, when you just do this, that's not going to take memory. That's just going to copy and replace. That's just going to be done before the software is compiled, right? So I don't spend memory. I don't take memory. And the really annoying thing is that you have to do static const total. It's a hassle. It's I don't like it. So a preprocessor is awesome. And now the only problem is that this preprocessor directive here, if you include this header somewhere else, you will see that this preprocessor exists, which is a little bit annoying, but there you go. It's kind of cool. Anyways, so that's why I decided to create a define. And there you go. So now we found a bug, right? I did 5 and 3. You can see there is a bug with how long the line is. So we gotta fix that, right? So let me see what the issue is here. So the issue is with this line of code here, where we need to figure out how long the horizontal line is. And total cells is okay. So total cells is 10 and 5, but here I'm saying I have 5 and 3. So these things have to match. All right. That's annoying. How am I gonna tackle this? Well, okay, I mean, I could just do total X. No, this is total lines. I just need total cells. How am I gonna make this nicer? Okay. How are we gonna make this nicer? So, total cells. What I have in my head is I just want to define the amount of cells I want. So I want 10 cells and 5 cells. And according to the amount of cells I have, it should figure out how many lines we need. And so if we're going to do it this way, that means this has to be a pointer now, which I really didn't want to do, but it looks like we need to make this a pointer because we cannot figure out how, like, I can't figure out how many lines I need before I specify the total cells. And in here, I have to put how big the array is at the very start, but I can't because I don't know how many cells I have. So I have to delay the array creation to later on. So essentially what has to happen, this is gonna be scrapped. This is now gone. This is now just a pointer. And those both of these are just pointers, right? And they need to be created in the constructor. So this is gonna be equal to a new int sfrect shape, and this is gonna have a total cells of x, actually y, and this is gonna have total x cells of x, right? So I'm creating I'm initializing the arrays after I figure out how many total cells I have, and so this is gonna be so hold on, let me horizontal line looks like this. How many horizontal line do I want? I'm saying I want total cells on x 10. So 10, 1, 2, 3, 4. I need 10 vertical lines. All right, so this matches. Yeah, okay, so this is correct. All right, cool. So now this is going to change slightly. This is going to be total lines dot y plus 1. Total lines dot x plus 1. Remember, the +1 is just to have an extra line. This is y plus 1, x plus 1. Alright, so this should work. Same exact thing. But it's gonna crash. As always, useful. Alright, so why did this crash? Why, oh, why did this crash? So I'm specifying how many I want horizontal lines. And I'm saying I want, ooh, because +1 is, no, +1 is, yeah, no, I can't do +1. I have to do the +1 over here. Yes, I need to do the +1 over here, not anywhere else. Okay, so let me explain what happened here. This crashed is because I basically said, hey, I only have 10 elements over here. I specified that I only have 10 elements, and then said I want to loop through 11 elements, but I don't have 11 elements. I only have 10. So this +1 is wrong. This +1 should be over here. All right, so this should fix that problem. All right, so if I press play, that should not work. Why that not work? An interesting question. That's a very interesting. Oh, because I need to do +1. No, that's the total cells. Total cells and total lines are different. Oh, I need to do +1 everywhere. Okay, so I need to do +1 everywhere. Hold on. So I need to do both of them here and here. That's my bad. There you go. That's fixed. But I don't like this. I don't like the +1 everywhere. So what I'm going to do, I'm going to create dedicated variables for those. So to figure out how many lines I need, right? So total cells, I'm going to have here SF vector y total lines, right? And so total lines is going to be equal to SF, or I'm going to do total cells plus SF vector to I 1 and 1. So extra 2 lines. And this is going to be just extra total lines at Y, total lines at X, total lines at Y, total lines at X, total lines at Y, and total lines. This is, in my opinion, at least, it's kind of a nicer solution. What's your problem? I did something calling by mistake. There you go. There you go. Cool. We have a grid, and this is really cool. Now, if I specify that I want a 3x2 grid, right, that should just work. I should have a 3x2 grid. And there you go. Cool. Because you're not adding to the total cells, you're adding to the H line and V line while still, yeah, that's correct. Yeah. All right, cool. So we got this covered. We have a lovely grid, which works perfectly fine. We can specify the position of the grid. We can specify the scale of it, the total cells, how big each cell size is, the line thickness, and the total lines. Yeah, that's awesome. One thing you need to remember, again, every time you type the new keyword, you have to call delete. So let's delete that. Delete H line, delete V line. Cool. And so if I press play, should work perfectly fine. All right. So now rather than just hard coding how many cells I want, I should accept it in the constructor. So whoever gonna call the grid constructor, he should specify how many lines or how many cells they want. So I'm gonna create an SF vector to F total cells. I'm gonna pass by a reference. I'm gonna pass by const reference, right? And so I'm gonna say total cells. Total cells. This is gonna look very weird. and I can't add these two because you're x plus 1 x plus. Okay, let me explain what I just did in a second. Okay, this total cells looks a bit weird. But let me just make the code work and then I'll explain it. So in here, okay, here's the thing. I'm gonna call this A, just to make this a little bit clearer. A, right? Okay. So this syntax over here, when I say, well, let me explain this. I have a constructor, right? And usually our constructors, they don't take anything. They have empty parameters. However, since a constructor is just a normal function, you could make the constructor take a parameter. In my case, I said, hey, whoever is going to call the grid class and call the grid constructor, they have to pass in an SF vector to F by reference, and it's a const reference, and it's called A. Right? In my case, this is just the total cells, but I'm just going to call it A just to make things a little bit clearer. But this is how many cells I want in my grid, essentially. And so, in here, I'm essentially calling the constructor here. And you can see, whenever I create an object, I'm calling the constructor, right? And this is complaining because it's saying, hey, this constructor you're calling, it requires some parameters. It's not default anymore. Like, it's not empty like this. Right? If it's empty, then it has no issues. But it's not empty. You have to pass something in. So in here now, I have to pass SF vector to F, and I want 10 cells by 5 cells. This should be vector to I, not vector to F. Vector to I, and this is a vector to I, right? Okay. So now this part is done, right? So I'm basically passing this 10 by 5, which is going to be equal to A, right? Which is being passed to the constructor, which is A over here. Okay, so what am I doing here? What am I saying with total cells brackets A? This is essentially the same thing as doing this. Total cells equal to A, right? This is literally what I'm doing. It's a little bit in a weird syntax. Now, the reason I'm doing this is because I want whoever calls the grid class specifies how many cells they want. And so if I pass the 10 by 5, I want 10 cells on X, 5 cells on Y. I pass it to the grid, which is going to be equal to A. And if I go to the CPP, you can see A over here. And I'm saying, hey, total cells is equal to A. So whatever the value of A is going to be total cells. So total cells is going to have the value 10 and 5, right? There you go. But I'm just going to go back to the whole total cells like this. So this might look a little bit weird when I have total cells. It's actually a little bit confusing. And usually there is a practice in C++ where whenever you make a variable, you call it m underscore like this. And the m underscore, the m specify that this variable is a member class. It's part of the class, right? So if I do m over here, now it's not confusing, so I can just do m underscore, right? So now, m underscore total cells is equal to total cells. Now this is not that confusing, right? And I think I'll go with this. I've never used this whole m underscore thing before, but I think I'm gonna start. And so we're gonna have to do a lot of refactoring for our code specifically to make it follow, even the RPG game, to follow this new convention. It's gonna be a little bit tedious to go through and just do everything, but you know, happens. Sometimes you have to refactor your code. But anyways, now I specified the total size or how many cells I want. Y, oh, this is I, right? And this is I. Total cells at I, total cells at I. Okay. So now if I press play, I should have a 10 by 5 grid, which I do. If I want a 2 by 2 grid or 2 by 3 grid, press play, I'm modifying it, I'm changing it from here, which is awesome. There you go. Cool. So now I'm modifying it here. I don't have to worry about the inner working of the class. I can pass the parameters from here. All right, this is awesome. This works perfectly. Now, the other question that you might have is, why did I pass it by reference? Remember, passing by reference means you're not doing a copy. So I'm not copying the data from one memory location to the other, right? And last lecture, we went through the memory. I showed you how the memory kind of works, and we kind of looked at that, which is kind of cool. But essentially, you're not doing a copy. But what does the const mean, right? The const essentially means you're telling the programmer, or you're promising, that if you pass by reference, I promise that whatever you're going to pass, I'm not going to modify it. Because you could very easily do total cells equal to sf vector 2I at 1 and 1. So now you're modifying this variable. And because it's a const, you're promising that you're not going to do that, right? Which is important. All right. So there you go. That's done. That's what the const means. But there you go. That's awesome. The other thing I want to pass in is the position. So same thing. I want to pass the offset of the grid from here. So that would be cool. So let's do const sf vector to f as a reference called position, right? And I'm just going to say position, and same thing. Just copy this over here. The position. I'm passing the position over here. So now I have to do sf vector to f. If I do 0 and 0, this essentially means that, well, the grid is going to have a position of 0, 0, so it's going to be at the top left corner, right? If I say it's 50, 50, or 50, 10, that's going to be moved slightly 50 pixels to the right and 10 pixels down. You can see it like that. Awesome. And again, I can specify these things outside the class, and I have to go in here and configure the class, that's the whole idea, which is kind of cool. Same thing we need to do with the cell size. So I also need to specify. So these are going to have to be now in multiple lines just to make it a little bit clearer to read. Total cells. Now this is the cell size. So same thing. Copy this, paste it. It's going to be I, and this is cell size, right? Same thing. Copy this, paste it over here, and these are going to also be multiple lines, right? This is the cell size, and the cell size is going to be over here. And now we have to again specify the cell size at the very end. So actually, I want to put the cell size over here in the middle. Because you said the position, then the cell size, and the total cells. I think this makes a little bit more sense. So the order kind of matters, right? And so now, position, right? And then cell size. It's going to be 16. 16. Right? And if I press play, that should be exactly the same. Oh, thank you. I'm glad you like it. All right, so this is going to be exactly the same. And if I change this to 8 by 8, that's going to be half the size. Awesome. Cool. So we're configuring it again from here. What's next? Scale, right? We need to specify the scale and the thickness. Those are the last two things. So scale, position, I can put the scale at the very end over here. So const sf vector to I, call it scale. The scale is going to be scale over here. Copy this. This is going to be our scale. And we need to specify at this point how this has to be in lines. Just to make a little bit more sense. SF vector to I, scale of 10, comma 10. So that should have the scale of 10 by 10. Right? And if I want to reduce the scale, make it 5 by 5, it'll be 5 by 5. And there I go, which is kind of configured, which is awesome. And finally, the last thing is the thickness, right? And so this is going to be a lonely integer. I'm not going to pass it by reference because it's just an integer. It doesn't matter. I'm going to call it line thickness. I'm going to pass it over here. And line thickness is going to be here. Right, and I specify the line thickness as 10 pixels. Huge pixels. A lot of pixels. Big pixels. Which you can see over here. Right? And so now I'm configuring the grid from outside. I don't ever have to go inside this grid to do anything, right? This is all configurable from outside, which is awesome. All right. So now that we're done with the grid, we're drawing the grid. It'd be really nice to specify the color of the grid, right? This is something nice that you could specify. So what I'm going to do is I'm going to allow that to happen. So I could say here const sf color. I'm going to pass my reference. I'm going to call it color. And then same thing in here. Right? And then I can specify the color here. I can say I need m color. To sf color m_color. I can say here m color is color, and when I set the position for every single one, I'm gonna also set color, set fill color, and the fill color is gonna be equal to m_color. Right, this is the vertical line. And so what I'm doing here, or what I'm gonna do here, I'm gonna say sf color, let's say 1,0,0,1, right? I'm specifying a color. So I'm specifying the red color. Why are you mad? This color. Color. Isn't the color at the very end? Nope. It's over here. There we go. All right, so now I'm setting the color to 1. 1 is red, right? So 1001, that's red. We talked about RGB before. Actually, these values are 255 values. Sorry, this is from 0 to 255. So 255, that will be red color, right? So I'm passing the color over here, right? Which means it's gonna be passed to this variable color. Color is gonna be passed to m color, right? M color now has the color red, and when I loop through my lines to set the size, the position, I set the filled color to m color, right? And that works, which is cool. Right, I'm specifying the color. What else can we specify for the grid? I think that's pretty much it, really. Right? So let's go to 2 pixels, and I have a red grid, which is awesome. And there you go. Cool. Cool. Okay. That's done. What I'm gonna do, I'm just gonna. So this is the position, right? So I'm gonna set it to 100 pixels by 100 pixels. 16 by 16 pixels. This is going to be 100 by 50. Scale is 1. Right, so I'm gonna have a lots and lots of cells. Right, so this is kind of where I draw my map, which is kind of cool, right? All right, and if I want, I can set this to like 128, not to be as bright on the eyes. So half transparency, which means it'll fade away like that. It's not gonna be as bright. I can make it even like 64. But now it's not gonna be as bright. It's gonna be, look how faded it is, right? Okay, so this is all good, right? This is all good. I'm just gonna make it to 5 because red is too bright. So we're gonna make it white. I'm gonna make this 128. Okay. So we have the grid. How long have I been streaming? An hour and 20 minutes. So we can do a little bit more, right? Okay, so what's next? Well, essentially, the next thing I want to do and specify is I want to be able to place tiles on the grid, right? That's what I want to do. Okay. So if you go to any map editor, right? Literally any map editor, essentially what happens, let's say I have a grid like this, right? My mouse, if my mouse is in the center and I move my mouse a little bit to the right, now here's the thing. Wherever my mouse is on the screen, it's gonna have a picture of a tile. So essentially I'm moving a tile, a single tile, a picture of a tile everywhere, right? And so to give you an example, let's go to map or tile map editor, right? And so if I go here, if the person clicks on a tile, a little bit clearer. If the let's go here. If the person clicks on a tile, one of those tiles, right, and moves his mouse, you will see that the tile will follow the mouse, right? And so if he goes on this grid and he moves the mouse slightly to the right, the tile will not move to the right. It will snap to this cell, right? The tile will snap to this cell. And if I move my mouse all the way to the edge, the tile will kind of teleport or snap to the next cell or shift to the next cell. If I move my mouse a little bit to the right, it will move to the next cell and so on and so forth, right? And so that's what I kind of want to do. The first thing I need to do is draw a tile, a single tile that follows the mouse. All right, where do we do that? I'm not going to do it in grid because grid just should draw a grid, nothing else. What I can make is another class. I'm going to call it mouse tile, right? Just call it mouse tile. That's going to be the tile that's following the mouse. Mouse tile, lovely mouse tile. Move over here. Right, save this, save this. Right, mouse tile is gonna have the same exact kind of structure our grid class does. If I go to my grid, I'm just gonna copy this. And I'm just gonna copy this all, I think. So this is my private section, this is my public section. I don't need any of this. Right, and there's gonna be mouse tile, right? I need the SFML class over here. And now I can go ahead and create all these lovely things. Which is awesome, right? And so now I have all of this, right? Nothing new. I'm going to create an object. I'm going to include this first. Include mouse. Spell include correctly. Mouse tile. I'm going to create an object out of it. Mouse tile. Mouse tile. Mouse tile.initialize. Mouse tile.load. Mouse tile.update. Now, mouse tile will require two things. It will require the delta time and the mouse position. Those are really important, right? And then mouse tile. Cool. This is going to be an SF vector to mouse position. So go mouse tile. I need the mouse position and mouse position. Cool. And if I press play, the code should run, no issues at all, or there shouldn't be any issues, which is kind of cool. All right, what's next? Well, we need to load a tile sheet. So I need to go to the world and kind of go here, right? So I need to open config folder. All right, so I need to go to my RPG game, assets, world, prison, right? And I need to copy the style sheet, right? Okay, so I'm gonna copy the same thing, literally the same asset, or just this world. I'm gonna put it in the map editor. This is my world over here, right? I'm going to load this texture in. So we are going to create an SF texture. Gonna call it tile sheet, and then SF sprite tile. Tile sheet is going to be equal or dot load from file, and we need to specify the file. And I believe we were doing that somewhere here. Ooh, I deleted this. What was it here? I think assets. You just go directly to assets / world / what was it? Prison / tile sheet.png. Right. I'm loading my tile sheet. My tile dot set texture. So I need to set the texture for my tile, which is the tile sheet. I need to draw window dot draw my tile, right? And in theory, this should work. At least in theory, what I think. There you go. It does. It draws the entire tile sheet. I don't want it to draw the entire tile sheet. I just want it to draw a part of that. So we'll pick an index, a random index. We'll figure out an index. Let's do tile dot set. What was it? I forgot the function name. If I go to map.cpp, what was it called? Set texture rect, right? I'm just gonna copy this code rather than writing it again. So the tile, the position, what's the position? This is gonna be, I don't know. I'm gonna say 32 pixels, 0 on Y. The width is 16 by 16 because we know each single tile is 16 by 16 pixels, right? I'm gonna put this all in one line, right? If I press play, it should draw only part of that small part. You can see that small part's over here. A little bit small, so I'm gonna scale it a little bit up. So dot set scale, and this is SF vector 2F, scale by 10 by 10. It's a little bit large, but it's fine. All right, there you go. I don't like this tile, so let's open this actual file and kind of figure out which tile I want. Which one of these tiles do I want? We can take this tile. I like this tile. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. 11 multiplied by 16 pixels. Whatever that value is. Whoops, not here. 11 multiplied by 16 pixels. Either 11 or 10. Yeah, 11. There you go. Cool. So this should follow my mask now. Okay. So all I'm going to do is I am going to say tile dot set position to mask position. So the tile should follow my mouse, in theory at least. That's what should happen. And there it does. Wherever my mouse goes, the tile goes. Which is awesome. Alright, I need to calm down this grid, like cool it. Like cool it a lot. Right? We're not gonna have 100 by 100 cells. Let's do 10 by 10 or 10 by 10 by 5. And let's do scale of 10. Scale of 10. right? There you go. So the same thing with the tile here. We should do 10 by 10, right? And yeah, there you go. We set the scale already to 10. So that's good. So now, okay, so here's what I want to do next. First of all, small problem. You can see that whenever I move my mouse, the tile is being set to the left corner, top left corner of the tile. I don't want that. I want whatever my mouse is, I want that tile to be the center of it, right? So that's what I want. The next thing that I would like to do is whenever I move my mouse, so this tile should be here, right? It should snap to this tile, to the cell. If I move my mouse to the right, it should snap over here, and then snap over here, and then snap over here, and so on and so forth, right? That's kind of what I want to do. Okay. So, let's do that, right? Now, behind this, there's a lot of explanation behind this. There's some math that needs to be done behind this, right? Okay. To make this as easy as humanly possible, to not confuse the math at all, I'm going to set the position to 0, 0, right? Right here. And so this should be a little bit easier to work with. Okay. So here's the thing. Whenever I have a grid, and I need my... Ow, sorry, I hit the mic. Here's the math behind this. If I go here, and I make a grid, right, let's say I make a grid, say this grid. Yeah, I know. Don't worry, it'll be good. Okay. Gonna make a grid like this. All right. This is my grid. It's too big. Let's just do this, 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 and this. Right? Okay. So the position of my grid, this corner over here is 0, 0. This corner is 0, 0, right? Okay. Let's assume, for argument's sake, that every cell, right, every single cell has a width of 16 pixels and a height of 16 pixels. That means the position of this arrow is 16 at 0, because on the x-axis we increment it by 16 pixels. On the x-axis I increment again by 16, so this will be 32, 0, this position, 32, 0. This position is, pick a different color. This position over here is 16, 0. This position is 32, 0. Right? And this position over here is 0, 0. And this would be 48, 0. All right, so that's great. Next, so this would be index 0, right? This cell will have an index of 0. This cell will have an index of 1. This cell will have an index of 2. Right? Actually, more specifically, this cell will have an index of 0, 0. Which will be an index of 1, 0. It will be 2, 0. Right? This would be 0, 1, 1, 1, 2, 1, 2, 2, 2, 1, 0, 2. Okay? And so these are the x-axis. So you can see the x-axis incrementing by 1 every time. So 0, 1, 2, because this is the x-axis. I'm going to the right. Then when I go down, the y-axis increments by 1. So 0, 1, 2, right? Very basic coordinate system. All right, that is done. We figured that out. That's great. So here is the thing. Essentially, what I would like to do is figure out the mouse position. I want to say if the mouse position is between 0, if the mouse position is between 0 and 16, right? If my mouse on the x-axis, right? If my mouse is between 0 and 16, the tile, my tile, should be its position 0, 0. So no matter what, if my mouse is anywhere between this range, between 0 and 16 pixels, the position of my tile on the x-axis should be 0. And the same thing for the y-axis. If my mouse is between 0 on the y-axis and 16 on the y-axis, anywhere between here, right? Anywhere in here, the position of my tile on the y-axis should also be 0. So anywhere in this box, the tile should be at the position of the tile will be 0, 0. Because if it's 0, 0, that means I'm drawing the tile over here, right? The tile is being drawn in this cell, like so. Like if I go and press play, the tile will be drawn over here. It will fill the cell. This would be 0, 0, right? This would not be 0, 0, right? My tile has moved half of the cell and half of the cell, right? Whatever position that is, let's say 8 pixels by 8 pixels. But here it'd be 0, 0. So if my mouse anywhere, if it goes anywhere in this tile or in this cell, if my mouse is anywhere inside this cell, this tile should always stay in here, no matter what. If I move my mouse over here, the cell will be here. If I move my mouse over here, this tile would be over here. However, if I move my mouse to the next cell, now the tile will be placed over here. If I move my mouse anywhere inside this cell, the tile will always be over here. If I move my mouse to the next cell, the tile will be over here. Even if my mouse is on the edge, the tile should be over here, right? And that's what I want to accomplish essentially. All right. So now that we kind of understand this concept, and if you don't, just for whatever reason, if that doesn't make sense, I can show you a visual. Right? From a map editor, I kind of made it a long time ago. I believe it's, yeah, here. So you will see. Yeah, notice this. Okay, so look, it's a little bit sped up. Let me slow it down slightly. Okay, so notice when I start the grid, right? Yeah, that's fine. That's fine. Okay, so I'm going to take one of the tiles, right? And then I'm going to move this tile. You can see that the tile kind of snaps wherever I place it. No matter where I click on the grid, the tile is snapped in here, right? And that's kind of my goal. Okay, so let's do that. So how does this work? Well, there's a little bit of math behind it. So essentially what I can do, the math formula behind this is this. Okay. Well, what we're going to do for the x-axis. Okay. So let's say my mouse position is in the center of the tile. Over here. What is this? What is this position? If 0, 0 is over here, and I know that this entire cell is 16 pixels on the width and 16 pixels on the height, what is the middle? Well, divide by 2, right? That would be 8. So on the x-axis, my current position of my mouse is 8. Okay, so what I can do is I can say this, 8 divided by 16. Why 16 is because the entire cell is 16 pixels. If my cell width was 32, I would divide by 32. If my cell width was 64, I would divide by 64, right? So essentially what I'm doing is I take the current mouse position on the x-axis. What is my mouse position on the x-axis? And what is my cell width? Okay, So I take 8 and divide by 16. What is the value of that? What is 8 divided by 16? Well, it's an easy math you can do. 8 divided by 16 is 0.5. Okay, 0.5. Now here's the thing. This is a floating point number, right? This is a floating point number. What I can do is I can convert this floating point number into an integer. What do you think happens when you convert a floating point into an integer? Does it become 1? Does it become 0? Does it stay at 0.5? Well, we know it can't stay at 0.5 because floating points, integers are whole numbers. It's either 1 or 2 or 3 or 100 or -5, right? It doesn't have a decimal point. What happens when you take a floating point number and convert it to an integer? It doesn't round up and it doesn't round down. What happens is essentially all the data after the decimal point is lost. So if this is 5.1238, right? I just delete everything after the decimal point. That's really it. I just lose data because imagine this an integer and you put 0.532, the box can only hold a 0, so everything outside the box is gone, right? So even if you have like 0.9, this goes to 0. 0.1, it's 0 because everything after the decimal point is gone. Okay. So we want to convert this to an integer. Converting this to an integer goes to 0. Now this is 0. And so my tile position on the x-axis is 0. Let's do the y-axis now. What is the position on the y-axis? So let's say on x is 8, but on y, it's let's say 12 on y. So 12 divided by 16. What is that? What is 12 divided by 16? 12 divided by 16. It's 0.75. So 0.75. Convert that to an integer. What is that equal to? 0. So my tile position, if my mouse position is at 8, 12, then my tile position is at 0, 0. And remember, that's what we wanted. That's what that's what I said. If your mouse position is anywhere inside this box, we want our tile position to always be 0, 0. All right? Okay. So that's good. That's done. What's next? Well, next, how about we try this cell, the second cell. So now, if my mouse is anywhere inside the cell, the position of my tile should be 16, 0. Okay? Okay, let's do that. Let's assume my mouse position is currently sitting at a lovely 30, 10. This is where my mouse position is. 30, 10. Okay? 30, 10 is around over somewhere here. Right where the red dot is. Okay, so let's do the same formula. Let's do the same math. So do 30 divided by 16, right? What is that equal to? Well, let's see. 30 divided by 16. It's 1.875. 1.875. Convert that to an integer. I'll close this. Convert that to an integer. What do you get? Well, remember, everything after a decimal point is gone. So what do you get? You get 1, right? So this is 1. Okay. Next, let's take the 10. 10 divided by 16. What does that give you? I think we used the 10. No, we didn't use the 10 example. Let's do 10. Whoops. divided by 16, 0.625. What happens if I remove, if I convert that to an integer? Everything after dot is gone. So this becomes 0. So my position is 1, 0. Okay? Now, here's the thing that I didn't do last time. 1, 0, you can see the position is 1, 0. This cell has a 1, 0. So what I can do now, right? Let's do the position 1, whoops, 1, 0. So what I do now is multiply by 16. So I divided by 16, I again multiply by 16. So what does that give you? 1 by 16 is 16. 1 by 0 is 0. So what is the new position? Well, the new position is 16, 0. So 16, 0 is over here. So my tile position will be over here at the very top, and it will occupy the entire cell if my mouse position is over here. That happens for anything. So if your mouse position is over here, you do the same exact formula. You take the mouse position, you divide by 16. Take that floating number, convert it to an integer. Take that integer, multiply it again by 16, and now you get this, right? You get the actual tile position, which should be at the top left of the screen. So no matter my mouse, where my mouse position in the box, it will always be, and I do this formula, it will always be at the top left corner of my screen. So I hope that made sense. I'm gonna do one last example, right? And I'm gonna do it on this cell over here. Okay? So what is the position of the cell? What is the top left corner of the cell? So this is 16 pixels and another 16 pixels. So this would be 32. So 32 on Y, and this is 16 pixels. So on X, it would be 16, 32. So this is the position here. So if I put my mouse anywhere in the cell, my tile position should be over here to occupy the entire cell, to fill up the entire cell, like so. Again, if I go to my kind of this thing, you can see if I put my mouse anywhere in this cell, the tile will always be positioned like this. No matter where I move my mouse inside this cell, the tile will always be over here and be positioned over here, right? So that's the formula we're trying to do. And so this is the position, 16 and 32. Okay. So let's say my position, right, my mouse position right now in this cell is over here. So this is around halfway on the y-axis and like few pixels on the x-axis. So if this is 32 plus 16, where's 32 plus 16? Not 16, sorry, 8. Because if this is 32 and I add 16, meaning I go all the way here. But no, I want to do 32 plus halfway, which is 8. What is 32 plus 8? 32 plus 8. That would be 40. So my mouse position on the y-axis, currently it is 40. And on the x-axis, it's a few pixels from the x-axis. So if this is 16, let's say 18 on the x-axis, right? So my mouse position is 18 on x and 40 on y. Okay, let's divide by 16 and divide by 16. What do we get? So 18 divided by 16 is 3. It's a solid 3, actually. Not 6. Wait, that didn't make any sense. I was like, what? How is it 3? Okay, 1.125. 18 divided by 16 is 1.125, equal to 1.1125. Okay, convert that to an integer. You remove everything after the decimal point, so you get a 1. What about 40? 40 divided by 16, you get 2.5. A nice, solid 2.5. So what is 2.5 converted to an integer? Is 2. Okay, So notice it's 1, 2. Let's look at the coordinates. It's 1, 2. Look, 1, 2. Kind of cool, huh? All right. So now what you do, you multiply by 16. You multiply by 16. What do you get? 1 by 16 is 16. 2 by 16 is 32. So the coordinates is 16 and 32. Let's see. Is it 16 and 32? 16 and 32. So no matter my mouse position on this grid, it will always be, I'm always converting my mouse position within this block to 1632. It'll always be 1632, which is awesome. This is really freaking cool, right? All right, so let's do this. Let's implement this. That is the entire theory. Okay, so my mouse position divided by 16, convert it to an integer, multiply by 16, and I get where my tile should be. Okay, let's do that. So in here, I should do the following. Int x equal to mouse position dot x, right? That's the first thing. I'm taking my mouse position and dividing it by 16. Divide by 16. Okay? Cool. All right. So I'm going to call this x, okay? And then I'm going to say int xx equal to x multiplied by 16 multiplied by 16, which gives me the value, right? So I need to do that again. Be y, 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 y. For y, I'm taking the mouse position, dividing it by 16. Dividing it by 16. All right? And I get the value. Converting it to an integer is just simply making a variable called int. It will just convert it to an integer, right? It will just put it here. Okay. Now this number is an int, which is 2. It's stored inside y. Now what I could do is do yy, which is 2. Yy. I'll take the, so this y is the 2, right? This is 2 over here. So 2 by 16 stored in yy, which is 32. I mean, I didn't have to do all this, right? I could have done it all in one line, but this is a little bit more understandable. And these variable names are fucking atrocious. So we're gonna make this more comprehensive, or not comprehensive. We'll make this a little bit more understandable, but this is fine for now. All right, so the tile position will be a new SF vector 2f. The position will be xx, yy. So now notice what's going to happen, right? One thing that's very important, we need to set the scale. The scale is important. So because we're scaling by 10, so this has to happen first, right? We're scaling by 10. If we didn't have a scale, this would not have been a problem at all. But we're scaling everything by 10, right? Okay. So you take the 16, and I need this to happen first, right? Because the division, everything is scaled by 10, right? So the scale is 10. So I need this to happen first. Okay. So now, in theory, this should work. Ooh. Okay. So look where okay. It's a little bit. I need to. Okay. Never mind. I need to multiply everything by 10. Okay. This whole thing by 10. I was wrong. Sorry. Whole thing have to be multiplied by 10, which is just, okay, I don't need brackets here. Wait, what? Oh no, it didn't. I forgot to multiply this by 10. So hold on, I might not be wrong. Let's see. Yeah, look, this is awesome. My mouse is anywhere inside the box, and it stays where it is. If I move to the next box, this is where it is. If I move to the next box, it is where it is, which is awesome. So my tile is moving one box at a time, which is awesome. right? This is really cool, huh? This is awesome. So it doesn't matter where my mouse is as long as it's in the box, the tile will still be here. I keep saying map. I'm sorry, I meant no, it doesn't matter where my mouse is as long as my mouse is in the box or the cell, the tile will still be where it is. And it's awesome, right? It's moving one cell at a time. It's awesome, right? All right, so I can make this a little bit better. I can make this the whole thing in one line. So first, I would like to do this, right, and then that. So I'm gonna do the same thing here. First, I'm gonna do this, then do that. This is not gonna work, and I'll explain why this is not gonna work because there's a concept I didn't explain to you yet. Yeah, this is not gonna work, right? Okay. Now, before it worked fine, right, with no issues. If I want to put this all in one line, I have to first. This floating point is converted to an integer immediately because I save it in an integer, right? However, if I want this whole thing to look like this, I first have to convert this to an integer. And this is called casting. So to convert one data type to another, you cast it from one data type to the other. So this whole thing is a floating point. So what I can do is cast this entire thing to an integer. So I'm casting all of this to an integer. And so by doing so, I can now just multiply this. And so if I put x over here, right, this should work fine. I didn't do the second one. I just want to test it real quick. You can see it works perfectly fine. But it looks a little bit uglier, right? You have this. You first, I mean, yeah. I don't think I need those brackets. Do I need these brackets? I don't know. Let's see if I need these. I don't think I do. Oh, I definitely fucking do. So, I first take this, divide it by 16 by 10, whatever 16. I do the multiplication first. When the multiplication is done, I divide this by this. I get a floating point. This floating point will be converted to an integer because I put an integer. This is called casting. This entire thing is a floating point. I am casting, so if this is like 2.5f, I am casting 2.5 into an int. I'm converting 2.5 to an int. And this is called casting, right? And so this will result into 2, right? So I'm taking this entire thing, converting into an int, and then multiplying it with this, right? And I don't need the brackets over here. Multiplying it by this, I'll keep the bracket just a little bit more clear, and then I get this x, right? So I can do the same exact thing. This will just be mass y. But I don't want to do this in 2 lines. So this is mass x, mass y. It looks much uglier, much uglier, but it works. There you go. You want kind of a shortcut. So there you go. Now instead of this 16, right, we're just gonna do a tile. We need this for the division. I think I'm gonna spread it into 2 lines because this one line is a little bit way uglier than I would like. Oh, very ugly. I don't like it. So I'm gonna spread this into multiple lines. This is gonna be tile.getScale .x, right? Same thing here. Tile.getScale.x. This is getScale.y. GetScale.y, right? And the 16 will be the tile size. So I'm going to create a new variable, sf vector to I, tile size. And this is going to be m underscore. And I forgot that I'm using this new thing now. This is sf vector to I, tile size. A reference on. So we went through all of this. I explained all this before, right? So I'm gonna copy this code. paste it over here. And same thing, just do tile size, sorry, m underscore tile size equal to tile size, right? And then here, this would be m underscore m. I'm just gonna copy this. M underscore m. There you go. Okay. So now I'm passing the tile size from outside again. Mouse tile is gonna pass it from outside rather than hard coding everything inside, right? Whatever the tile size is, this will be m underscore tile size dot x, m underscore tile size dot whoops, yeah, dot x dot y, just dot x dot y dot y, right? And instead of xxxx, this is going to be int x, int y, going to be called x and y, x and y, right? So now I have to specify how big the tile is, right? And so in here I do sf vector to I, b16 and 16. I need to specify the scale. I cannot specify, I shouldn't put the scale here. So again, I do sf vector to I, m underscore scale, right? So tile size, comma, scale. This would be tile scale, right? The same thing here. Copy this entire line. Would be on multiple lines. Tile scale, m tile scale. Why is it not happy? Oh, comma. Got the comma. This would be tile scale. Why is it not happy? Oh, it wants a vector to f. Well, fuck you. What are you gonna do? Oh, it has to be a vector to f, because what if you want the scale to be a little bit... Yeah, okay, vector to f. Vector to f. And there you go. And instead of doing on this whole thing, just do m tile scale. Alright. And so now let's specify the scale also. So sf vector to I, scale is 10 by 10. And that should work perfectly fine. No issues. A lot of issues. This would be f over here. Again, this would be on multiple lines. And one line is fine for now. And there you go. This works perfectly fine. So let me explain what I've done. Essentially, now, whenever you call this class, which is mouse tile, you have to give it, you have to tell it, what do you want the tile size to be and the tile scale to be. And again, this is passed by reference and const, so you don't change them and so on and so forth. And so we're doing this again. I'm saying tile size, I'm saying m tile size equal to tile size. So m tile size is over here, right? Equal to tile size, which means that I can access this variable, or m tile size will be accessed throughout the class, the entire class. This 11 is going to be hard coded for now, just for now. We'll deal with it later. But here I'm using, I'm just the m tile size and the m tile scale is being used throughout the class, right? So again, what is going on, or what is happening, right, is essentially very simple. I put this side by side. I'm doing this. This is a variable, right? I am specifying the variable over here. Right? The first parameter, or the first input, is the first thing, right? If I zoom it, or you can see the second parameter is the tile scale, right? So the first parameter one second, I'm just seeing how I'm made all this. Okay. So the first, that's fine, whatever. Okay. So the first parameter, right? This is the first parameter over here, which is tile size, which I pass it over here. The second parameter is the tile scale, which I also pass it over here, right? Somewhere over there. So what is happening? This is equal to tile size. And then I'm saying the tile size equal to m tile size. And I can use m tile size in every single function, right? So the reason I have to pass this into this variable and then pass it again to another variable is because this tile size can only be accessed in this function, which is the constructor. Tile size only exists in the scope, right? The scope of the constructor. And so I cannot use tile size somewhere else in a different function. So that's why I have to go, hey, this is equal to tile size. And then I'm saying m tile size equal to tile size. And because m tile size, because that is in the class, which means every single function can access m tile size, right? Every single function can access this variable. And that's why I need to pass things. I need to take this, pass it over here to tile size, and then from tile size, I need to pass it again to m tile size. And m tile size, I can use that in this function, in this function, in this function, and every other function, right? And so that's kind of important. All right, so I'm doing that. That's all done, which is awesome. It's cool. I'm configuring my grid. I'm configuring my tiles, and my tile is moving, every cell by cell, which is awesome, right? All right, so I think I'm gonna end the stream over here. Right, we made a lot of progress, which is awesome. The next time, what I want to do is now I have to click. If I click with my mouse button anywhere in this grid, I should be able to place a tile, right? Which is pretty cool. Now, one problem, this is one slight problem. If I offset this grid, so if I say the grid is an offset of 100 or the position is 150, this whole thing breaks. Like the tile, you'll see the tile will not be inside the cell anymore. Right, and that's why I said I don't want to overcomplicate it, but it doesn't exist, like it doesn't do this. We will fix that next time, or you can try fix it and figure it out if you can, which would be really awesome. But that's really it, what I want to do for today, right? I'm gonna commit the code, and yeah, so let me commit the code. All right, so what did we do? We did a lot today. So today, created a map editor project, or created the map editor project, created a grid in the map editor, created a, what else? A tile that follows the mouse which snaps to the grid. That's it. Created map editor. Okay, commit all this, push all of this. All right, it's pushed. It's done. Good to go. So that's it. I'm gonna end it over here. I would love a subscribe button. If you guys could hit that, that would be fantastic. If you actually made it through the entire lecture, that would be awesome. This is awesome. So a like would help a ton. That would also be awesome. And if you'd like to ask any questions or anything, always you can join the Discord channel or Discord server that I created. It's gonna be in the description of every lecture. That would be cool. If you want to download the code and check out the code, everything is on GitHub. It's free. You can grab it, do whatever you like with it so far. And yeah, if you have any questions, as always, comment section is right here. You can ask any questions you want, or you can post them in the Discord channel, Discord server. But yeah, hope you guys enjoyed this. And I will see you guys next time. When am I gonna stream next? I don't know. Maybe tomorrow, maybe next week. No idea. We'll see. But have a good one, guys. Talk to you later.